Logic gates. Logic gates are an electronic circuit which has one or more inputs but only a single output is called a gate. So this gates inside contains transistor, diode, and so it depends. There is always logic relationship between input, output of a gate. Hence, more precisely, is called a logic gate. Logic gates are basically of three types: OR gate, AND gate, NOT gate. So the symbols for OR gate is this one, and the symbol for AND gate is this one, and the other one is NOT gate. This is the symbol for NOT gate. But based on this, we can have this one NOR gate or NAND gate or exclusive or exclusive or buffer. These are the important logic gates. So we can use also. Okay, so the input to a logic gate can have only one of two values, that is 0 and 1. It can be low, example near 0 volt, inside near 0 volt indicated by 0, or it can be high, example close to supply voltage, it's approximately 5 volt or 5 to 6 volt indicated by 1. So these two values are 0 and 1. 0 and 1. A truth table for logic gates indicates the output for all possible values. These are the truth table for logic gates. Now let's start from the first one, from AND gates. When these are two inputs, A and B are the two inputs. Here we have the output. You can indicate either by C or whatever you want. Let's say when you start from this side, you have to write 0 1 0 1, and next one is 0 0 1 1. The next one is 0 0 0 0 1 1 1 1. Okay, now when both of the inputs are 0, the output in AND gate will be 0. When one of the input is 0, the other is 1, the output is 0. When one is 0, the other is 1, so the output is 0. But for AND gate, if both of the inputs or all of the input, you may have 3 inputs. This is the first input, the second, you may have another input, 4 input, and so on. If each one of them is 1, so the output is 1. But if one of them is 0, the output will be 0 in case of AND logic gate, sorry. So the other one is NAND gate, which is the opposite of AND gate. As you can see here, the output is 0 0 0 1. For NAND gate, the output will be, instead of 0, it will become 1. Instead of 0 here, 1. Instead of 0 here, 1. And the final one is 1, but here we get 0. This is for NAND gate. Now let's see what will happen for OR gate. For OR gate, you can indicate by A plus B, but for AND gate, A dot B. Okay, so 0, when both of them is 0, the output will be 0. But if one of them is 1, the output will be 1. The output will be 1. 0 1, the output is 1. 1 0, the output is 1. 1 1, the output is 1. If you have 4 input like A, B, or C, D, so among these A, B, C, D, if one of them is 1, the output will be 1. But if all of them is 0, the output will be 0. Now let's see NOR gate. So just like this one, NAND gate, NOR gate, when the output is 0, this one for NOR is 1, which is the opposite of this. When this one is 1, this is 0. So for NOR gate, this is the 3 of them is 1, here 3 of them become 0, which is the opposite of the 1. So here we have the output will be reversed in case of NOR gate that we have for OR gate, and for NOR gate, which is the opposite of the outputs that we have for OR gate. Okay, so NOT gate, when the input is 0, the output will be 1. When the input is 1, the output will be 0. Now let's proceed to the next one. Okay, so these are the different truth table for AND gate. OR gate, or exclusive OR gate. In case of this exclusive OR gate, if one of them is 1, just like OR gate 1, but if both of them is the same, 0 0, the output is 0. If both of them is the same, 1 1, the output is 0. But if one is 0, the other is 1, 0, the other is 1, then the output will be 1. And we have seen what NAND gate, we have seen a NOR gate, but exclusive NOR gate, if those of them is similar, which is 0 0, then the output will be 1. 1 1, the output will be 1. But if 1 0 0 1, so the output will be 0. The output will be 0 in case of exclusive NOR gate. Okay. Okay, so these are just if you have AND gate, OR gate, NOT gate. So you can indicate by this one mathematically. X for AND gate we put dot, A dot B. For OR gate we use plus. For NOT gate, like this one, like a complement. And for exclusive OR gate, plus with a circle. Based on all this, okay, we can write the output of this gates connection. These are the inputs. A and B are the input. The input for this OR gate, the input for AND gate. So this AND OR gate and AND gate, they are connected, and or the output of this OR gate will be the input of this AND gate. The output of this NAND gate, sorry, will be the input of this AND gate. Now let's find what will happen to the output. For example, for this one, A and B are the input. So if it is OR gate, for OR gate, the output will be, for example, X will be A plus B. So the output here is A plus B. But for NAND gate, it's A dot B with a bar. A dot B with a bar. Because for AND gate we have A dot B. But if it is NAND gate, we have to use bar. So for this one, for AND gates, A plus B and A dot B bar are the inputs. Therefore, this is the AND gate. For AND gate, the two inputs will be, we use dot product. So this is the first input, which is A plus B dotted with A dot B bar. So A plus B dotted with A dot B bar will be the outputs, the final output of this logic connection. You may have a number of connections, a number of inputs, A, B, C, and so on. So with that, you can exercise. Okay, so this is connecting of different logic gates. So it will be the end of chapter 6. So